Hello, I'm Jonathan DeJesus, and this is my video report for homework 4. So for our first program, we were to create a program that allows users to enter in an integer, and then our program is meant to reverse the integer that they enter. So my program starts with declaring an int variable of n, and then asking users for an output or for input, and then storing the input into n. We then call the reverse method, which pretty much does the bulk of the program. So for the reverse method, we have three variables up top: a reverse array, a temp variable, and also an I variable. Our while loop here pretty much is what reverses the number. This while loop goes as long as the number that the user entered is greater than 0. So it goes as long as there is a valid number to reverse. So our while loop starts by using modulus 10, and what this does is remove the last digit of number, and it stores into this temp variable right here. We then store this temp variable into the next element into the array. And lastly, we use number is equal to number divided by 10. And what this does is remove the last digit of this integer. We end this while loop by incrementing I plus plus, which adds I plus 1, which will ensure that the next while loop iteration stores the next temp variable in the correct spot in the reverse array. We then use this for loop here to output the correct number. It's just a simple for loop. And here I'm just going to test my program. I'll just test it by entering 1, 2, 3, 4, 5, 6, 7, 8, 9. Just simple. And here you can see it reverses it properly. It reverses 9, 8, 7, 6, 5, 4, 3, 2, 1. So you can see that my program does reverse numbers properly. So for our second problem, we were to create a program that finds all twin prime numbers from 0 to 1,000. And to do this, I made a first for loop, which iterates from 3 all the way to 1,000, and does this in increments of 2. And what this does is ensure that it iterates through pretty much every single odd number from 3 to 1,000. So for the next step in this problem is to find whether or not the number provided by this for loop right here, which is I, is a prime number or not. So we do that using this second for loop right here. And this for loop goes from int j equals 2, and then it goes from I minus 1, and then also increments by 1. So what this does is take the number from the first for loop, for example, let's just say 5, and it pretty much divides it by every number before 5 all the way to 2. So it'll check if it is divisible by all numbers from 2 to 1 minus 5, which is 4. And if it is not divisible by any of those numbers, then we know that the number is prime. So if this happens to be divisible by any number from there, then we know that it's not prime. So prime 1 is equal to false. And so we break from this for loop, and we pretty much go back to this initial for loop to find the next prime. So once we figure out whether the first number is prime, then we prepare to figure out the second part of the twin prime number, which is whether 2 plus the first prime number is a prime number. So once prime 1 is true, we go on here, and this for loop pretty much does something similar to the first for loop. This for loop goes from int k equals to 3, and then ends from k is less than I plus 2. So this iterates from 3, and then also ends at I plus 2. So what this does is pretty much compare I plus 2, which is the second number of the twin prime, and sees if it's divisible by any number from 3 all the way to 1 less than I plus 2. So let's iterate from all those numbers, and if it is not divisible by any of those numbers, then we know that it is a prime number. So then it goes to here. So it goes here, and if prime 1 and prime 2 are true, then we simply see out I and I plus 2, which are the twin prime numbers. So I'm going to go ahead and test my program. You can see this is the output. Let me drag this down so you can see all of it. And here is a Wikipedia post, which pretty much shows all the twin primes from 0 to 1,000. Or it's not Wikipedia, actually, just some random website I found. And you can see that these numbers are pretty much identical. So you can see my program does do the twin primes number from 0 to 1,000 correctly. So for our third assignment, we will create a program that has a bunch of arrays. The first one is used to store the names of the employees, and the second one is an integer 2D array, which is used to store the number of hours worked on a given day. So every single row stands for a unique employee, and every single column stands for the number of hours worked on the given weekday or weekend. I made a third totals array, which stores the totals of the number of hours these employees worked on a given day, because the point of this program is to eventually output the employees and their totals in decreasing order. So I started by making a for loop, which is actually a nested for loop, which iterates through the 2D array and then adds up pretty much every single value in a given row and adds it to a totals integer right here. We then take this totals integer and then add it to the given element in the totals array here. So after pretty much incrementing through an entire 2D array, we have all the totals. So we have pretty much everything we need to eventually sort this totals array right here, which is done right here. So to sort these arrays, I pretty much just use the bubble sort again. The bubble sort uses two for loops in order to sort. This first for loop pretty much allows this sort to pretty much iterate through the array multiple times. And the second one here is what does most of the work. This one pretty much iterates from 0 to 5 minus I minus 1 and iterates j plus plus. And here we can see that it does, if total j is less than total j plus 1, then this switch pretty much occurs. So if the first element of an array is less than the second element of an array, then we pretty much swap them. And this pretty much occurs until we have the smallest value of this array, and that is stored at the very end of the array. We then are done with this second for loop, and we go back to the first for loop. So we iterate through the for loop again to find the second smallest number, and we store that in 5 minus I minus 1, which would be at the second to the end. Then we do this all over again until we pretty much have a fully sorted array. And also this is 5 here because the total array has 5 values in it. So once this bubble sort is done sorting, we have a fully sorted array. So we swap the values for the totals array, and here we swap the values for the name array. And this is important because we need to output the correct order for the employees and their hours. So finally, we just have a for loop here, which we just use to output the name and the score for the employees. And when I run my program, here you can see it sorts names properly from largest to lowest values. So for our final assignment, we were to simulate a tic-tac-toe game. And I started by making these int variables for the column and rows for the X and O players to enter in their moves that they wanted to make. I made bool over is equal to false, and this pretty much over stands for like whether the game is over or not. So this while loop over here runs while there are no winners. And I made this grid, this 3x3 grid, which is a 2D grid array, which is used to store the current state of the game board. So this while loop here runs while the game is not over, and pretty much is used to take input from the user for their given move. So here's the input gathered for player X. We take the row and the column, and we make grid equal to Rx minus 1 and Cx minus 1. And we use this minus 1 so we can we tell the user to enter in values from 1 to 3, but we know that arrays use values that start at 0. So we -1, so we can have the correct spacing and ordering. So we make the row and the column at the enter equal to x, and this marks the grid as their move. And we do the same thing for here for 0. And after this, we print in we call the method for print grid, and this is used to print in the current state of the board. And also we use an if statement, and we call if is game over inside, and this pretty much keeps track of whether or not there are winners and losers. So I'll scroll up here to explain the methods that I made. So our first method is print grid, and this pretty much just prints out the current state of the game board. So we have a double for loop for outputting in the values in the 2D array. And we pretty much just use these little pipes right here to have like proper spacing. So we just use this for loop to pretty much just see out the 2D array pretty much. So for the second method, which is bool is game over, this method returns a bool value that pretty much determines whether or not there's a winner or not. And its argument is the char grid array. So this first if statement pretty much goes through every single case where x is a winner, and x is a winner when there is an x value in pretty much a straight line anywhere on the board. So if there's a horizontal line where there's an x, there's a vertical line where there's an x, and also where there is a crossed diagonal line in the board, then we know that x is a winner. So that's covered through pretty much all these numbers here. If there's an x value through an entire row, then there's a winner. And the second row, if there's a winner, and the third row, if there's a winner. Also, there's a line through the first column, there's a winner. If there's a line through the second column, there's a winner. And there's a line through the third column, there's a winner. And finally, if there's diagonal lines, this takes care of it. So if there's a diagonal line like this or diagonal like this, these two statements will take care of that. And if any of these are true, then we know that the game is over. So we just see out player X wins, and we return, the method returns true. So this down here will break. So this A statement will be true, and this will break out of this while loop here, and the game will finally be over. We do the same thing here for player 0 or player O, and this just does the exact same thing here, except we check if there's an O in this for the elements in the array. And if there are no winners, then we continue with the game, and this returns false, so this while loop will continue. Also, real quick, I made a quick change to my program. So previously, my program didn't take into account draws. It only took into account whether X or O would win. But to do this, I made a count integer, which keeps track of how many turns there are per game. So here in the main function right here, for every move made by either player X or player O, we add a number to the count. And in between, so the only way that the game would end in a draw is if player X would make a move and that move doesn't end up winning the game. So if count is equal to 9, and the game is not over, which is checked by this method right here, then we know it's a draw. So we print the grid out and we end the game as a draw. So here I'll just check my program real quick. So I'll have to speed through this because YouTube does not allow for videos to be longer than 15 minutes. So here you can see is my first test to make sure that my tic-tac-toe game can properly simulate in the event someone wins.